All right. So last time we started looking at the measures of central tendency. Then after looking at the measures of central tendency, we are supposed also to start looking at the measures of dispersion, which are also called the measures of variability. So we have a very good example here. A good example reads that you have the data set of the test results scored by students in a statistics test. And so we have two classes. There's class A and class B, and these are the results. So from the data given, we are asked you to calculate the standard deviation and to calculate the coefficient of variation for each class. We're supposed to use the results obtained in C to, to assess which class actually was more consistent in their performance or performed better, or justify the answer thereafter. So let's try to go through this. How do we find the mean? Just as we said last time, we said the mean of ungrouped data like this one. This data is not yet grouped. It is found by saying the summation of the x divided by n, where x are just the individual scores in each class, that is our x, and then n is just the score points, how many they are. So for example, let's start with class number A. To find the mean, we'll have to add all of them. There's no need of arranging them in ascending order or descending order. You can just sum how they are. So you can say okay. Sorry, I had just been logged out. Where is it? So I was just saying that you have to to sum up the individual scores in class A, where we have 34 plus 42 plus 36 plus 38 plus 45 plus 40 plus 32, again plus 34 plus 39 and plus 41. We divide by how many they are. We say they are 10 students. So what is our total score on top? Like when you sum all the scores, what do we find? If you summed them already, what did you find? And just punch your calculator.
I found 381.
381.
381. Mm-hmm.
Divided by 10.
Correct.
Then when we divide by 10, what do we find as the mean?
38.1.
38.1 as the mean. All right. Is there any question? Okay. Assuming that there is no question, then we can go to class number B. Class B as well is that 21 plus 24 plus 32 plus 64 plus 50 plus 35 students or scores plus 28 plus 30 plus 42 and plus 55. Then you divide all that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are also 10 students as well. So what is the total score?
Uh, 411. I don't know, but that's what I found.
411. Do we have anyone else finding different scores? $411. Do we have someone finding a different score?
Yeah, apparently I'm getting the same 381. I don't know. Let me run through it. 381.
You can try to do that. $381. 381.
Yeah, 381.
Uh-uh.
21,
Okay.
24, right?
Finally, you are also agreeing. Did you try to redo your work?
I'm redoing it just now.
Okay.
Oh yes, it's 381. 381.
381. So we still have the same mean. 3 point, 3 point what?
81.
3.81.
81. Point. Huh?
Oh,
38.1. 38.1.
Okay, 38.1.
Yes.
Okay. Calculating the standard deviation now for ungrouped data like this one. We did say last time that the standard deviation shall be given as the square root of the summation of the x. These are the individual scores minus the mean, and then you square that divided by n minus 1. So what is our x? So for example, let's start with A. So we will have 34 minus the mean, you say it is 38.1 squared plus the other one is 42 minus 38.1 squared plus 36 minus 38.1 squared plus 38 minus 38.1, that squared plus 45 minus 38.1, that squared plus again 40 minus 38.1, that squared plus 32 minus 38.1, that is squared plus 34 minus 38.1, that squared plus 39 minus 38.1, squaring that, plus 41 minus 38.1, that squared, and divide by 9, right? And 10 minus 1 is 9. So let's try to calculate on top. We see what we find before we can square root it. It's a lot of work, but since there are many people calculating, it shall be well. We are trying to calculate so that see what we can have. 2 minus 8.1, that squared plus 34 minus 8 squared is equal to plus 39 squared plus 4. Okay. And 152.5. Okay, you can also be calculating. This is what I'm finding. But I've just done it once. Have to try it again severally, maybe twice. Divided by 9. What are we finding? Or you are having math error? No, you cannot find math. Hello? Are the people calculating?
Yes.
What are you finding? Or you are still calculating?
The top parts are found 147.89.
Oh, interesting. 147 point.
89.
0.89 divided by 9. Anyone else doing it so that we hear, try to compare agonies when all of us find different answers. or what is finally finding? Are you calculating, madam?
I am, but I'm a bit confused here. So, in terms of calculations, what I'm doing is I'm supposed to subtract, is it 34 minus 38? So when I find the answer, I square root the answer, is it?
Not square root, square the answer. Square the answer.
Oh, then I go to the next one just like that.
Mm-hmm.
Then I was doing something wrong.
Just do the way how it is appearing here. That's what you do. Minus that 8.1 square.
Then I square root it.
Don't square root, square it.
Or square it by 2. Okay.
Let me try it once more. And I check the consistency. 38 minus 38.1. That square is plus 45 minus 8 squared plus 40 minus 8.1. That squared plus 32 minus 8.1. Squaring that plus 84 minus 8.1. Squaring that plus 39.38.1. 9 minus 8.1. Squaring that. 41 minus 38.1. Squaring that. When I did it again, it gave me 150.9. 150.9. Okay. How many of us are calculating? 3, 4.
Was this calculator? Studying it.
Studying the calculator. Okay.
You told me to buy last time. So
did you buy the calculator?
I did. I'm saying I'm studying it. I'm lost.
You're studying the new calculator.
I'm lost. I can't lie.
Where are you lost? You don't know how to put power 2 to square. Where is the challenge?
I think to square. But then last time I did. I think it's different. I don't know. Is it where there's x2?
Yes, x to the power 2. That's where you square from.
Okay.
Just try to do that. It should write the way how we are writing.
Okay.
Is it doing the needle?
I think it is. I hope I'm doing the right thing. So when I added the first one, it has given me like 1451.61. Is
On
it
top.
before I go ahead and continue? No.
Just
like before, I haven't finished. Just the first part, like the 34 minus 38, and the square. Then I square it.
Put it in the bracket. Oh, I see. Put them in the bracket. The way how they are appearing here. Just the way how I've displayed
That's how
them.
I put on the calculator.
Yes.
On the
Yeah.
oh okay.
Yeah. Mm. Let me do this for the last time. We see where we are lagging behind. Don't worry, we'll reach where we are going. It's okay. Hmm. It is 150.9. I found this twice. Maybe someone else to do again. Mine has given me this 2 times. Okay. Okay, the main thing is that we have gotten the idea. Let's get the idea in the meantime so that yeah, this is how it is done. So you can say 150.9 divided by 9, and then you square root this. Okay, so 150.9 divided by 9 is 16.7666 carrying up to 7. Then you square root the answer. Square root of the answer is 4.09 as the standard deviation. Did you get it? Okay. All right, people got this one. Then we can go to B. Let's do B again. We find the standard deviation too. So for A, SD is 4.09. So for this one, it will be 21 minus 38.1 squared plus 24 minus 38.1, that to be squared, plus 32 minus 38.1, that to be squared 2, plus what, 64 minus 38.1, and that to be squared, plus 50 minus 38.1, that to be squared. Then 35 minus 38.1, that to be squared 2. 28 minus 38.1, that to be squared. So that you can also say 30 minus 38.1, that to be squared, plus after 30 is what? 42. 42 minus plus 42 minus 38.1, square that, plus 55 minus 38.1, you square that 2 and divide by 9. Let's start doing this together. So you have 21 minus 38.1, you close the bracket, you square, plus 24 minus 38.1, you square that, plus what? 32 minus 38.1, you square that, plus 64 minus 38.1, we square that, plus 50 minus 38.1, close and square, plus 35 minus 38.1, we square that. Plus 28 minus 38.1 square that plus 30 minus 38.1 we square plus 42 minus 38.1 we square that plus finally 55 minus 38.1 we square that. So on top I find 180 18.9. I don't know. Who is finding the same? Who is finding the different answer? We are all solving this and we are in this together. One squared plus what are the people finding? It's indeed a big number. I still find the same thing. Do we have other people finding the different thing? Okay. Let's do this. Assuming this is okay, then we can divide this by 9. 18.9 divided by 9. Then we'll have 202.1 and the square root the same. So you can say the square root of the answer. Oh, so the standard deviation is 14.2 for class B, following the data that we have just calculated. So SD equal to 14.22. Right, 4 and 14.4 or 0.22. Is that clear? So I found the standard deviations, yeah? Okay. Now that you find the standard deviations, the next thing that you're asked of finding is the coefficient of variation. The coefficient of variation, very, very important to know how to find the coefficient of variation. So the coefficient of variation is found by saying the standard deviation divided by the mean, x bar. Okay, that's the formula. Times 100 is expressed as a percentage. Let's do for A. So for A, we found 4.09 divided by the mean was 38.1 multiplied by 100. What do you find as the percentage for as the coefficient of variation for class A? Hello? Am I logged out? You just divide 4.09 divided by 38, you know, times 100. What are you finding?
10.73.
10.73%. 73%. Okay. Okay. Then we can do for class B. For class B, we found this SD to be 14 point what? What was the SD? 18.9 divided by 9 and the square root of the answer. Okay, 14.22 to be divided by 38.1 multiplied by 100. Okay, divided by 38.1. That is it. What do you find? Should be a huge standard deviation.
37.32.
37.32%. Okay, so these are the coefficients of variations that you have found, 2 of them. Then you are told to, number one, use the same answer, okay, and assess which class was more consistent in their performance or performed better, okay. The one that was more consistent in the performance and they performed actually better. Which class was more consistent?
I think class B. Oh, no.
Why do you say so?
Okay.
Okay. So the coefficient of variation, it does measure, actually it measures the level of dispersion around the mean, or the level of variability around the mean. It gives us how far the individual scores revolve around the mean. Okay, so usually the higher the coefficient of variation, the greater the level of dispersion around the mean. Okay, the higher the coefficient of variation, the greater the level of dispersion around the mean. Okay, so if the coefficient of variation is bigger, it means that there were a lot of dispersion, right? A spread around the average score. Okay, so it means that for class C, the one that has got higher, what's this, higher coefficient of variation, it means that they were not consistent around the mean. Okay, the individual scores had a higher level of dispersion. So therefore, the class that was more consistent is that one whose coefficient of variation is smaller. Is that clear?
Yes.
So class A was more consistent, right? It was more consistent. Is there any question? Okay. Do people have any questions? There is no question, sir. Finally, do you have a question today?
No, I don't, but then I'll just try to go through the calculations, like the one where I was lost on the square root part. I just have to start the calculator. Otherwise, I think I'm okay.
But you have gotten it, how to square.
Yes, yes, I've gotten it. So I'll go through as
Okay.
soon as we're done with class.
Yeah, practice again and again. Master your calculator this time around. And don't go with a new calculator in an exam. Make sure you understand your calculator bueno. Because what usually happens, people go with a borrowed calculator, then it starts giving them the answers that they don't even understand in an exam. And that is what happens sometimes. Please master your calculator. Don't borrow a calculator. Understand your calculator. If you don't have a good calculator, buy in advance. Use it right now so that you understand how it works. Okay. And take care of it. A practical question is here on the measure of central tendency and dispersion. An annual profit made by a random sample of 40 companies that are in the banking industry are shown in the table below. So these are the classes 10 but less than 20. These are classes from 10 to 20, from 20 to 30, from 30 to 40, then from 40 to what is it? 50, and from 50 to 49. These are classes. Then the number of companies, this is the frequency, okay, is the level of frequency. Is that clear? So we are asking to find the mean. This data that we have now is a grouped data. It's different from the data that you had previously. The data you had previously was not grouped. It was indeed ungrouped data. So given ungrouped data, given ungrouped data that you were given, you need to manage to handle these questions. So we taught you how to handle the ungrouped data. Now we are also showing you on how to handle the grouped data, right? So how can you do the calculations and computations for the grouped data, right? How do you do the computations for the grouped data? Let's show you how to find the mean for the grouped data. Very important. So for you to find the mean for the grouped data, number one, it may be difficult to get the entire class, the entire group here. So what you do, you find what you call the midpoints, okay? Find the midpoints here, the midpoint. After finding, can you find the midpoint? You're finding the midpoint. What is the midpoint? The midpoint is found by adding, what are you adding? You're adding lower class boundary plus the upper class what? Boundary. Right. So let's add. So 10 plus 20 is 30 divided by 2, giving us 15, yeah? And the 20 plus 30 is 50, giving us, divided by 2, giving us 25. So that we can say 30 plus 40 is 70, giving us 35. And this will be 45, yeah?
Yes.
So that is it going to be 45? 90, yeah. 50 plus 60 to what? 110 divided by 255.
55.
This is how you find the midpoints. Is that clear? Then on this side where we have frequency, this one I've told you is your frequency. We can find the cumulative frequency. To find the cumulative frequency, you start with the first frequency that you already have here. Then you start adding the frequencies. 3 plus 7, it will give us 10, yeah? Then 10 plus 16, what are we going to find? 26. Then 26 plus 10, it should be 36. So that 36 plus 4 gives us what? 40 companies. Is that clear? That's called the cumulative frequency. You are adding up the frequencies. Is that clear?
Yes.
Okay. If that is clear, then it is well. So for you to find the mean of a grouped data, it is found by summing up frequency times the midpoint. The midpoint. Let's call our midpoint our x. Let's just put x for our midpoint. So that you say f of x divided by n, which is just the summation of the frequencies. When you total up all the frequencies, that is how you find the mean of the grouped data. So what this means is that you're multiplying x times the frequency, right? On top. Summing up means, after you add this product, frequency times the x. That's what you're finding on top. Let's find that. So we are finding 15 being our x times the frequency, 3 plus 25, the x, times 7, the frequency, plus what? 35 times what? Times 16, plus 45 times 10, plus what? What are we plusing? Plus 55 times 4. Is that clear? Then you divide by the total frequency. The total frequency is summing up all these, adding them together. It should add up to 40. Just add 7 plus, just 3 plus 7 plus 16 plus 10 plus 4 should give us 40. Are people getting this? So you can do what we were doing previously to find the top part. 15 times 3 plus 25 times 7 plus 35 times 16 plus 45 times 10 plus 55 times 4. What are you finding on top? My good friends, what are you finding on top? I find 1,450 to divide that by 40. What are you finding? Find yours too, or confirm with me. Okay, it's finding the same.
No,
So
1,450.
Okay. All right. So when you divide, what is our mean?
36.25 or
36.25.
We can't round off.
Yeah, we can round off to 2 decimal places.
Oh, okay.
Okay. Have you seen the difference between finding the mean of a grouped data and ungrouped data? For ungrouped data, you're just summing up the scores. But this data you have now is grouped. Is that clear?
Yes, it is.
All right. It is clear, sir. You can proceed. Okay. Finally, are you following?
Yes, I am.
Today you are following. Okay. It is okay. So let's find the median. How do we find the median? Now you listen attentively when it comes to the median. So the median for ungrouped data, you remember how we are writing it? We are arranging the numbers in ascending order. Then we start canceling and canceling, right? That's for ungrouped data. But this data which is grouped, if you want to find the median is found by the formula. The formula is the LM plus the, usually the prof gives formulas to you people. If he will do what he did, he has been doing these other years, then you will have the formulas. the formulas. You will have formulae. Okay. Then Fm, everything multiplied by C. Now, what do these these letters stand for? This is the LM is the lower class boundary. It's the lower class boundary of the median class. Okay, the median class. The lower class boundary of the median class is LM. This one, we'll show you how to find it. The lower class of the median boundary. Then summation of F. This is the addition of total frequency divided by N. N is the number of sample size. We already know the, or it's not N, you divide by 2, sorry. This should be divided by 2. Yeah. And then CF, this one is the cumulative frequency. The cumulative frequency for the class boundary. For the class boundary. The cumulative frequency of the class boundary, that is before the class of the median, right? Before the median class. The cumulative frequency, okay, that is there for, that is all there in the class, that is just before the class boundary. I'll show you how to do the cumulative frequency as well. And the FM is the frequency of the median class, where C is the class size. The class size. The class size is C. Okay. Let's find them. Let's start with the LM. So the lower class boundary, how it is found. First of all, you have to determine which one is the median class. Okay. So for us to know the median, you just get the total N, the total sample size or total frequency divided by 2. There are 40 students, right? There are 40 scores. Then you divide that by 2. That gives us 20, isn't it? Mm-hmm. 40 by 2, we get 20. Now, so you add these frequencies where there is 20. In which class can we find 20? So you can have, there is the 3 plus 7, that's 10. Then 10 plus plus what? Plus 16 is 26. So 20 is in which class? Is in this class, right? It is in the class between 30 and 40. Mm-hmm. Are people following? So the 20, the median is in the class. This is the median class now. We have known what we have established what the median class is. Okay. All right. So now for us to know the median class, or to get the median class, what we are supposed to do is to, this is the easiest thing you can actually do, so that you don't really get confused. The easiest way is to, you may even relate this to 20, then from 20 to what? To 30. There's 20 to 30, 40, 50, and what? And the 60. These are the classes that you have, and they have their own frequencies. Okay, this one is ending from 50. So when you're finding the LM, which is the lower class boundary, the one that is just before, it is just before the mean. You get the upper class boundary before the mean, before the median class. So the upper class boundary before the median class is which one? It's 30, isn't it? Are people following? People don't get confused. Are people following? Have you seen the upper class boundary before 30? Before the median class is 30, right?
Yes.
Yes. Then plus the lower class boundary, the upper class boundary between the upper class boundary for the class before the median class plus the lower class boundary of the median class. Now, apparently what has happened for this class, the upper class boundary here is also equal to the lower class boundary of the median class. You've seen that, right?
Yeah.
Sometimes you find that these are different numbers. Here there is a different number, also here a different number. Is that clear? Then you divide this by 2. What are you finding?
It will be 30.
It will be 30 as the lower class boundary. When you get the lower class boundary, what should come next is the summation of f, right? The summation of the frequencies 40 to be divided by 2. That gives us 40. So we already have this one, summation of f divided by 2 equal to 20. Oh, not 40, equal to 20. Right. Then what we need now again is the class, the cumulative frequency. Okay, the cumulative frequency of the class just before the class boundary, before the median class. So the median class is this one. We have already established what a median class is, right? This is our median class. So there should be the cumulative frequency before the median class. What is the cumulative frequency before the median class? Is 10, isn't it? The median class is this one. The cumulative frequency before the median class, this one, the TFBC, that's the cumulative frequency before the median class is 10. So this is equal to what? It's equal to 10. Are the people following?
Yes.
Okay. Now, if people are following, then oh, and why would I delete this? I have just accidentally deleted this. Okay, it is well. Let's find what are we finding? The class boundary. So it was 3, the cumulative frequency was 310, 26, 36, and 40. We need to find the class boundary C. So with this one, we just differentiate between, we subtract between the difference of the upper class boundary. And so the upper class boundary is found by saying, this upper class boundary of the median class, our median class is which one? Between 30 and 60, right? And 40.
Yes.
Yes. So this upper class boundary plus the lower class boundary of the next class, of the class that is after the median class. So it's 40 plus 40. You average that still gives us 40. You get. So that gives us 40. So the upper class boundary is going to be 40, then minus the lower class boundary. The lower class boundary is the same one that you have found, the lower class boundary is found by saying, getting the averages that we had found here. For the lower class, this one, the upper class boundary of the class that is just before the median class, and the lower class boundary of the median class. We averaged that and found 30, isn't it? We averaged that, we found 30. So the class size is 10, or the class interval is 10 as well. Is that clear? Yeah. So found that the cumulative frequency that is just before the class that has got the median, or the median class, is 10. That is our CFBC is 10. and also our C, the class size, is 10. So you just have to put these now into the formula. Your formula for the median, of the grouped data is LM plus the summation of the frequency divided by 2 minus the class cumulative frequency of the class boundary, that is just before the median class, divided by the frequency of the median class times the everything times the C. Okay. So our lower class boundary was what? Was 30, right? It was 30 plus the summation of F. This one was 20 divided by, was 40. Summation of frequencies was 40, right? Divided by 2 minus the CFBC was 10. Then everything divided by the frequency of the median class is which one? Our median class, we said is this one, isn't it? So the frequency there of the 16, then everything to be multiplied by 10, which is the class boundary, the class interval. So 2 into 40 is 20. This one will be 20. And the 20 minus 10 is 10 over 16. Right. That will be 10. Here will be 10. You will have 10. Then you can say 10, 16, 10 divided by 16. What do you find?
0.625.
0.625 multiplied by 10 again, this other 10. That will be 62 point what? 0.5. No, is to be 6.25 plus 30. So that your median can be what? 36.25. Is that clear? Hello?
Yes, it is.
Right. We have found the median. Very, very important. There is another question that I want to add. I know it's not it's not here. How to find a mode? There are those questions that will ask you how to find the mode of a grouped data. You know how to find the mode of a grouped data. Just look for the most frequent number, isn't it? That's what we say. The number that appears many times. But what about the mode of a grouped data like this one? Mode. So the mode is found by LM. It has got the same connotation. Then you have the delta 1 divided by delta 1 plus delta 2. All that multiplied by C. Where LM as well is still the lower class boundary. The lower class boundary. The lower class boundary, that's the LM. Then the delta A, delta 1. Delta 1 is actually the change. Okay. It is actually the change. It's a difference between the frequency of the median class minus the frequency of the class before the what? The median class. I'm saying the difference between the frequency of the median class minus the frequency of the class before the median class. You got that one? So the difference between the frequency of the median class minus the frequency of the class before the median class. That's delta 1. Delta 2 is the difference between the frequency of the median class the frequency of the median class minus the frequency of the class that is after the median class. Is that clear? Of the class that is not the median class, the model class, sorry, the model class. So the model class is the one that has got the highest frequency. Okay, I'm used of saying the mid. Yeah. So the model class is the one that has got the highest frequency. In this case, this one will be our model class. Is that clear? This is going to be our model class. So you look for the frequency of the model class, which is 16, minus the frequency of the class, okay, that is after the model class, which is 10 in that case. That's how we find delta 2. Is that clear? So you start finding the parameters. Let's find delta 1. Let's start finding delta 1. What is delta 1? Delta 1 is found by saying 16 minus 7, which is this class before the model class. What do you find?
9.
It's 9. Then delta 2 is found by saying 16 again minus 10. What do you find?
6.
10, this one. 6. Right. So you have found delta 1, delta 2. Then the class, this one, the class size. We have already found the class size, isn't it? In the previous example, 10. It's still the same way of how to find the class size. So it's 10. So you can put here the lower class boundary, okay? The lower class boundary of the model class. Of the model class, not of the median class now. The model class. It's still the same. It's 30 plus the other 30 divided by 30 is still the same. So you have 30 plus delta 1 is 9 divided by 9 plus 6 times the class boundary is 10. Right. Don't worry, you will be fine. And so you have 30 plus 9 divided by what? By 15 times 10. What is 9 divided by 15?
0.6.
0.6? Okay, so 0.6 times 10.
6.
It will give us 60 plus 30. That will give us 90 as the what? As the mod. I'm hoping that you have calculated well. Divided by 15. 0.6. Okay. Yeah. So any question? Okay. How do you find the standard deviation now? The standard deviation, yes, sir. Have we missed this?
So the 90 that we just found is the, which means this is that which means that 90 is the highest is the number with the highest frequency in the data set.
Remember, these are profits. Don't remember these. You've seen these profits. These profits are in hundreds here. So this is 20. It's 2,000. You've gotten it. Like it's not. How should I explain? Like it's a profit. Yeah, it's not for those scores. You remember the previous one we had the scores. So they're not connected question.
Yes.
So it means that
this one is 90,000 was the
no,
highest
not
score of it.
90,000. 90 plus 2 zeros. You know, there are 2
2
zeros.
zeros. Oh,
So it's 9,000. So like
9,000.
most of
Okay.
the companies were scoring 9,000 on average.
Okay.
That was the most, yes.
Okay, okay, I understand.
Okay. So it shows that there are zeros here. So you have to add the zeros. All right. About the standard deviation, just endure a bit. Just endure a bit. I know you are tired of this long lecture. For the grouped data, it's still, you find frequency times what? X minus X bar, then you square that, you divide by the summation of the frequency. That is the standard deviation of a grouped data. So just the same way how you were writing, you start with the frequency now, okay? You had found the midpoints here first. The midpoint, these are your X values. You found the, what was this? 15, 25, 35, 45, and 55, isn't it? So these are the X values, these are the frequencies here. So you would start, if you are to write in this formula, like you would start with the frequency number. And for example, in the first class, you'd write 3 times, then you get the X. The X is what? 15 minus the mean that you have found. What mean did we find? I've forgotten the mean. We found the mean for this question. What was the mean? It was the 1450 divided by, was it 40? What did we find? Hmm. 36.25.
25, yes.
36.25. That's the mean. Then you square that. Again, you go to the next score, which will be 7. Start with the frequency 7, then times the 25 minus the mean again, 36.25. Again, you square that. So you continue just like that. When it comes to the issue of commanding the calculator, you command it exactly the way how I have written here. And then the denominator will be the summation of F. It's already 40. We know that when you sum all the frequencies, they add up to 40. So your denominator will be 40. Whatever answer you find, you square root it. That is how you find the standard deviation. Is that clear? So the formula says you start with frequency. So frequency times the X minus X bar, the mean, you square that. Then plus you go again to the next class, frequency X, then minus the mean, you square that again. Frequency 16 times the 35 minus the mean, you square that until you finish all these and you divide by 40. Then your answer to be square rooted. And that is the standard deviation. Is that clear? Does someone have a question? Okay. So it is just like the same one we had. This one, again, it was saying, use the results from above to describe the distribution of the annual profit in the bank again. So you can do the coefficient of variation too again. Okay. Can use the coefficient of variation again. You know that the coefficient of variation is the standard deviation divided by the mean, X bar. That will give you the variations, the level of variations. Okay.